get started. So this, I'm organizing this 3 sessions, and there was a little bit of confusion in the invitation, probably the way that I worded it. And so just to be clear, during the workshop in Delft, I already spoke a bit about semantics, and it was a very high-level end-to-end presentation. Here I'm going to specifically focusing on what it is that we can do or should do or have to do to connect our various living labs using the FEDeRATED ontology and the semantic technology, right? So the reason why this may have been confusing is that in the initial invitation, I didn't put in the word interoperable or something like that. And so some of the recipients of my email thought I was talking about semantics in general for the living labs. And as you'll see, living labs may have their own semantic models, okay? So that is not what I'm talking about. Really, it's about how can we connect our living labs together using these technologies, okay? So that's what this is about. I actually put in a slide to make sure that I didn't forget to start the recording, but that's done. So I think we're good to go. As a recap, what is the objective for this session? Firstly, we need to look at our living labs, and I'll say a lot about living labs. So whenever I say that, just think about your living lab. So which part of your living lab could interact with other living labs? And as you'll find out during my presentation, that is not so easy to determine, and not as easy as we thought it might be. But anyway, we'll go into that and find out how we can actually do that. The second question is, once we figure out if we can actually interact with another living lab, is, okay, what data elements do I need to do that? And how do I find these in the federated semantic model? And so we'll look at the model and we'll do some work together there to find out, okay, exactly what is it that I can use in my interaction with other living labs. And then the third one, and I kind of already showed a little bit during our presentation in Delft, is how do I prepare the data for the interaction? There are 2 more sessions that I'm planning. The next one is about once we have our data, how do we actually make it available to other living labs in such a way that you can actually access it via the internet, via HTTP. And then there's another session on, okay, once we have the data, so we can cooperate with each other or between a couple of living labs perhaps. We now have the data. How do we access that data using queries? Okay, so 3 sessions. After this one, I'll send an invitation for the next one, but I thought I didn't want to confuse people, so I did just the first one, the planning, and the next one will be in a couple of weeks, I'm sure. All right, so that's the objective. The first thing that I asked myself is, when we talk about federated interoperability, and I had a discussion with a few of you, I also had it with Roland, is, well, what exactly is federated? You know, we know we're in the federated project, but what does it mean? So I did something that I've done before in the days when I was doing software development, and we had to do what we call user requirements analysis. And so there's a trick that works really well, is I took the short descriptions of our projects, the ones that are now on the federated website. Each project has its own description with its objectives and the main focus areas. I took all of that information and I did a word cloud. And what you can see from this is actually what are the main themes that connect all of the living labs. And you can see them here. There's a lot of them. I can't remember if it's 50 or 100 or something, more like 50, I think. But the next thing I did is, okay, what are the most important concepts that we find in all of the descriptions of our living labs? And here they are. And so with a bit of luck, none of this will come as a great surprise to you, because this is something that we all do in our labs, or most of us do in our living labs. I don't think there was any exception that didn't do cargo tracking of some sort. Okay, so that is something that we all have in common. A lot of the living labs are focusing on supply chain visibility, which goes a little bit with the tracking part, but it goes deeper than that. More insight into what is happening during the transport process. The next one that a lot of living labs have in common is to actually focus on the platform interoperability, and specifically on the multimodal platform interoperability. The next thing that, and it kind of links to the previous one, is that a lot of the living labs are implementing data sharing platforms. And then one that not everybody had, but many, is around asset infrastructure optimization. And just to be clear, I didn't pick these out because I thought they looked nice. This is literally an analysis of the text that we produced together. And I think it's pretty representative. So hopefully you recognize this, at least, I'd say at least 3 of these you'll find in your lab. I'm almost certain of that. I did read through all of them, so I didn't see anyone that was really very different. So coming back to the question on what is federated? Federated platforms is this, right? So if we do this, then chances are we can suggest that we're focusing on federated platforms. So the first question that I put out there, or the first thing that I said we were going to do, was how to identify which parts of your living lab could interact with other living labs. Now, just to clarify that, like me, I'm sure that you have looked at perhaps all of the other living labs or some of them, but the one thing you would have seen is when you ask yourself, well, how does that relate to my lab? And chances are that it would be hard to answer that question. There are some labs that have a very clear correspondence, and others you say, well, yeah, I can see how these federated ideas are implemented, but I don't see how it relates to my lab. And so we have to go one level down and accept that not all of our living lab activities are necessarily interoperable with others, but some of them are, and we'll find them which they are. So here's I try to show sort of the multimodal side of things here, where we have the various transport modes. We have the road, rail, inland waterways, maritime, air, and other transport, which may or may not be covered by labs, but there are other modes of transport, as you know. And each of them have infrastructure, which may be on the port side, or it may be on the transport side. Then each of them have their own environments, you know, like we have air traffic control, we have vessel traffic services, lots of different implementations of ways how we manage these various transport modes. And so here I have a proposed, not a definition, I wouldn't go as far as that, but what is federated platforms? So one way to describe it, and there may be many other ways, and it's an interesting debate to have, is they are digital platforms that support a logistics or transport activity, and they exchange data with other platforms using federated architecture and semantics. I think that if we look at a platform and it sort of matches that description, then we could argue that this is a federated platform. And so if you ask yourself that question, is the answer yes or no? Do you believe that you have a federated platform? And let's maybe ask that question. Is there anyone here that thinks that their living lab doesn't match that description for some reason? And chances are, if that's the case, then maybe this definition needs to be expanded, or this explanation. But does anyone have any comments on this so far, on whether or not this is a reasonable way of describing federated platforms? If you do want to speak, please unmute. I can't actually see hands or anything because I'm in presentation mode. So just shout or speak quietly. No, fine, no problem. So let's go with that, okay? So essentially, we're talking about digital platforms that we use in logistics and transport, and that can exchange data with other platforms using the federated architecture and semantics. So here is how a real transport might look like if you go on the multimodal transport. So for example, here I show how you may have an origin of a transport of cargo that initially uses the road system in order to be taken to a port and then subsequently be transported by sea. Then subsequently on arrival, it then gets transferred to a terminal for rail transport, and then it might go back to the road again, perhaps for a last mile delivery. And what you can see from this little picture is actually how quickly this becomes quite complicated. The other thing that certainly for me, I only know air transport quite well, but when I look at this, I really had to look up those terms. That some of them are meaningless to me. I don't know what a vessel traffic service is, but I know it exists. So you can see that unless you are an expert in many modes of transport, you'll quickly find yourself in an area where perhaps you're not that comfortable. And that's partly why we do have a federated environment, so that we try and use a common language, coming back to language that I described last time, so that we can talk about similar things without necessarily being expert at each other's transport modes. And so another way of describing federated platforms is to ask yourself the question, is there some involvement of multi-parties or multimodal transport logistics? And the multi-parties can happen within a single transport mode, right? You'll see that in a minute, but there's lots of parties involved. So again, it's another question in order to narrow down what it is that your lab can do with other labs is, are you involved in multi-party or multimodal transport? And if the answer is yes for one or yes for the other or both, that will help you understand what other living labs you may be able to interact with. So that is something to keep in mind. It's a question. It's more of a question than an answer. So another way to look at what we're doing in our living labs is to look at the business and commercial process. So one way to look at this is the question, firstly, I need a logistics service, right? I need a transport service. How do I find these? I find them and then say, okay, I need XYZ type of transport. You then get into the process of planning and getting quotations for that. Once you're happy with that, there may be some negotiations, some back and forth. You get to the order and the booking part of the process itself. Once all that is done, we get into delivery of services, and then we can, complete the commercial process, send an invoice and pay. And I realized that there's many ways of drawing this process, many standard ways even, but this is one way of looking at it. And so another question that you can ask yourself about your own living labs is, are we involved in that part? Or is this something that isn't really part of the scope of our project? Because it could be that you're purely focusing on the execution of services without actually engaging with the business and commercial process. So again, it's a question, are you involved in this or not? If the answer is yes, then perhaps there's another living lab that is also involved in this, and we can actually start looking at, can we link up the business and or commercial process? If you're not involved in this, then that is not an area where we look for interaction between living labs. We can also look at the operational side of things, is the actual transport of the goods. And let's just focus on the colors first. Again, there's different ways of looking at it, but a lot of transport modes have a lot of similarity in that freight will start with a consignor. There's likely to be a forwarder involved in that. There may be some warehousing as well. Somebody actually has to load the goods onto whatever type of mode of transport we use, whatever carrier. We then on the other side, on arrival, have unloaders. We have other forwarders taking over. Apologies, that should have been the destination forward, not origin, of course. And then the consignee finally takes receipt of the goods. There's other parties involved. We have authorities that may interact with the overall transport as well. We have customs that is involved as well. And so we have lots of stakeholders. And so chances are that your living lab is focusing on this part and not on the commercial part that I just mentioned before, but more on the operation side of things. In other words, the stakeholders you're dealing with maybe on this diagram here. And then if you look at the actual process that happens almost at every step of the way, is that there's a planning cycle, freight gets picked up, may have to be accepted before we can actually move on. We may initiate some tracking process, which may lead to updating milestones and forecasting. There may almost certainly be exceptions in issue management, and there may be disputes. So all of these things could also be part of the scope of your living lab. So it's good to understand whether or not any of this has a link to the work that you're doing or that your living lab is focusing on. Some very again, we dive deeper, and all of this is to get a good handle on where does my lab meets another lab. Okay, so you can look at the services that your lab is providing. So it could be that you are about transport tracking. I've seen a few labs, for example, that are using IoT or RFID. And so this could be an example of somebody whose focus is on transport tracking, and therefore that may be interested in working with another lab that's doing similar things, but perhaps for a different part of the transport. Supply chain visibility, if that's the focus, what exactly are we making visible? And can we share that visibility with another platform that's doing similar things? Multimodal data sharing. Are we trying to share data across the modes? And if so, then we have that challenge of understanding the complexities of the other mode and how do we actually share the data? But you may be involved in that, in which case that would be an interesting case to study as well. Some of the labs are looking at infrastructure optimization. Again, something that may be useful when looking at other infrastructure that is connected somehow. So these are just a few, but there may be other services that your lab is providing, and it's good to be clear about what it is, so that when we engage in a discussion with another lab, we can be clear about which services can we connect and which should we ignore. Then there is the focus of the service itself. Is this a transport service or an infrastructure service? Are we at ports or terminals? Back to what I said earlier, is this more about business process or commercial facilitation? Are we purely focusing on operational service delivery? So again, what is the focus helps a lot in understanding, so that when we try and match up different living labs, we're doing that in such a way that the services can be meaningfully connected. If they're not, I mean, if you're focusing on infrastructure, then that may or may not be useful in the business process context, right? I can't tell, but it's important to have that clear for yourself. And I think this is the last one, and then we'll try and pull it together. But then there is what I refer to as the interplatform process, okay? If you are interacting with other platforms, what is that exchange? Are you going to be checking with the other platform if the identity of the other party is something that you recognize, that you can validate? What is the services that you're actually sharing across these two platforms? What is the information that we would be sending or receiving? Are there other processes that are involved? And so we're now really bring it down to two living labs, X and Y, speaking to each other. And you get the questions like, well, what do you want to know from me? Or I want to know something from you. So we really start talking about an exchange between platforms. And of course, this only makes sense if we understand what the other party can provide in terms of services and other types of interaction, other process. So once we're clear on that, each lab should be able to be very clear on what is the service I provide. Okay, in this case, it's probably not one of our labs, but it's an orthopedic surgeon. But when we see that, we know exactly what this doctor is going to do for us. And we need that clarity in our own living labs as well. Can we really be explicit about that? Once we know that, what is the data that we need to exchange to be able to provide these services in exchange with other platforms? And then the third component is around process. And I have examples of all of these, so don't focus too much. But we do need to understand the process in which the data is exchanged for the purpose of providing a common service or a interoperable service. I think I just want to stop here for a minute. Did this raise any questions or thoughts so far? I can't see who is participating if their hands are up. So I don't even know if there's anybody still left on the call, but any feedback?
It's Gunnar here from Sweden. I'm not an IT guy, but so far it's good. I can follow you so far, and I'm happy for that. Really, it's good so far. Thank you.
Okay, that's really good news. If I lose you at some point, don't hesitate. Just raise your hand. I mean, that will be okay. If I lose you, then let me know.
Yeah, excellent, Henk. I think it's very good explained. Quite clear on what service, what data, the process. What's the scope of the process? Is that our internal process, or what process is that?
So this will be process. Okay, that's a good question. If we think about an exchange with another platform,
yep,
that will involve some sort of process.
Oh, okay, you mean the exchange process?
Yes, exactly. And that is actually quite a limited part. It could be. Let's take a very pragmatic example. Let's say that we're in a process, that we're in the business of providing quotes for a transport service and making bookings, right? Yep. There's a very clear process there. I want to go from A to B. I want to use this type of transport. These are the conditions. What is the price? Okay. And if it's dangerous goods, how does this change? So these are the sort of process exchanges you would have then. It's a conversation. It's essentially that.
Okay. Good. That's clear.
And any other comments? Okay. Let's go on then. You've seen this slide a few times. I've shown it a few times that the federated semantic model, which is central to what we're talking about here, is something that we have created to provide a common language for interacting between the various modes of transport. And as I showed earlier, each mode of transport has its own complexities that are not complex if you work in that mode, but if you're not in that mode, it will sound like a foreign language to you. And so we've come up with these common terms, and we'll dive into them a bit later so you can really see that they're actually quite simple, but they do allow us to interact between these various modes of transport. Now, going the wrong way here. If we, when we talk about the semantic model, the one on the top there, the federated semantic model, it's only about how we interact with each other. It is not about how you interact within your own living lab. And so I've drawn these black boxes here, and these are your living labs. And let's say that I know nothing about them, which is almost the truth for that matter. What happens inside your lab happens inside your lab. And we can be very, very sort of pragmatic about this. As far as I'm concerned, if you're in Sweden, you may well be using Swedish inside your living lab. I don't have an issue with that. It's fine. It's a black box. Whatever happens inside your lab stays inside your lab. Let's say it like that. And so you may well have your own semantic model in your lab, or you may have something that resembles a semantic model. It doesn't matter. It could be a data model. It could be anything. But you have something inside your labs, and that's fine. It stays there. It's a black box. But in order to interact with other living labs, we are suggesting that we need to use the federated semantic model to do so. So regardless whether you use Swedish in one and Italian in the other, as long as when you exchange data with each other, we use the terms that are defined in the federated semantic model, then we're fine, okay? So just to clarify that was the question that was raised when I organized this session, that some labs thought I was going to talk about what happens inside that black box. And no, I'm not going to talk about that, which doesn't mean that you're not going to learn things that are useful for that, but that's not the point of this. It's really about how do we interact via living labs. So let's go down to the next level and to actually try and analyze our labs to do an interactive process between us. Whatever questions you have in your mind at the moment, I think you'll find answers coming in the next few slides. So firstly, very important one, what exactly is it that we can interoperate with? Are we going to be, I have some examples in a moment. For example, do I have a transport service that goes across a number of countries, takes me to some sort of a hub somewhere, to a terminal, and then I have a last mile service that delivers the rest, right? So we have two different services. There's the cross-border services from one terminal to another, and then I have last mile delivery, which is another service. And so when we talk about what's the scope of the interoperable service, it will be that, is I have a international transport and I link it to a last mile service. So that will be an example of a scope, right? There are other examples where perhaps in multimodal transport, we have freight arriving at an airport. It then needs to be put into a truck and taken to a terminal where perhaps it gets moved on by rail or otherwise. That's another interoperable service that may be using the services of different labs, more than one lab. So once we are clear on that scope, and it's quite important, and it doesn't have to be complex, we'll see an example, but we need to be clear on what that is. If we can't verbalize where we're going to interoperate, then we can't do anything. But once we have verbalized that and agreed on the scope, we can then look at what is the process, what data is being exchanged, and what's the process for that exchange. So in the example I gave, I have a cross-border transport that takes freight to some sort of distribution center, and then we have a last mile delivery. So I can be clear about where it comes from, who is the actual final consignee, who are these parties that were involved. So we can really start describing what is the data that we need to be able to execute that if they're delivered by two different parties, by two different labs. What is the process for doing that? What's the exchange? If we were to speak about it, what are the questions? What are the statements we're making? That's the process. Once we have that, it then becomes a relatively mechanical process. We can translate it into a suitable format. We can host that data, and then we can do the queries. Those last two boxes are for the next sessions, right? So we don't have to worry about that. But the first three we'll be covering in this session here. So that's overall, that's what we're trying to do. And ultimately, if we do this properly, then I think we will have delivered one of the most important objectives of the FEDeRATED project, which is interoperability across multiple platforms. That is what we're trying to demonstrate. So this would actually get us there. Now, what you'll see in the second session, actually, we'll talk about hosting semantic data. We're going to be using some shortcuts. So it's not like in a few weeks from now, we're ready, because we're not. But I think we will have demonstrated that things are possible. We'll understand the scope much better of how we can interoperate across living labs. And it will define a very clear roadmap for how far we can go or want to go into actually making this a fully operational, interoperable environment. Okay. So, as I said, there's some sessions that are session 2 and 3. So let's not worry about those for now. The first one, actually, the first two is something I'm going to give you some homework. Well, actually, this is it. This is the homework, is that you're going to have to define what is the scope of interoperability of your lab. And when you do that, what are the processes? And we'll walk through some examples so you can take that away and think about it and meditate on it. But that's not something that I can do for you, because I don't know enough about your lab. It's really only the people that are working in the labs that have a full understanding of what services they could go outside their own lab with, right? So that is something to take away. The next part is, I think, is easier. It's purely analytical. Once you know what it is that you can do, to determine how to do that is just an analytical process, and we'll see an example. But there I can help. The first part I can't help. The second part I can help. Then the rest of it, the translation is relatively easy. We'll see an example, but again, we can help there as well. For the rest, you know, I wonder if this is covering my screen. Let me just get rid of the, oh, what have I done? Okay, I think I just lost my presentation. Let's go back to that. There we go. And so when it comes to the semantic data hosting, as I said, we'll have some shortcuts. We'll do it really easy. And then when it comes to the queries, I think what we'll probably do is provide you with some standard queries that you can play around with. But actually, once you get to that point, it becomes really easy. But we can formulate some queries that you can execute on your data or on the data of the other labs that are involved in this. So again, this is for session 3. Okay, this is the first part. The next part is what are the elements of the FEDeRATED semantic model that that would match the data and the interaction. Now that's maybe a bit of a mouthful, but it assumes that we already know who we're interacting with, which is currently probably not defined for most of the labs. So just a few words about that. So in preparing for this, I did something that I don't know whether it was a good use of my time, but I did it anyway. I took all of the summaries and main emphasis that each living lab provided to Alessia, I think, and it's all on our website now. We have all of the 23 labs there. And I just put them in little boxes, and I put them on a big sheet of paper, electronic paper, and wondered if I could start making connections. And so I went a bit further. I also looked at, okay, what modes of transport are these labs doing? Who are the main stakeholders? What are the topics that they're covering? And there is some overlap, of course, as you would expect. I mean, there are topics like tracking. There are topics like IoT. There are topics like perhaps infrastructure optimization. There are stakeholders that are the same, maybe customs. Okay, so I did the sort of a high-level analysis, and my thought was, well, all we have to do is make some connections between one lab and another lab, and then it kind of makes sense. And I realized that there are some issues with that, and it's probably one of the reasons why it's taken us a little while to get to this point where we really have to answer that question: is how do we interoperate? So starting on the left, you've seen this list here, right? I started with that the characteristics of a federated platform, certainly of our living labs, is that they're involved in cargo tracking, supply chain visibility, et cetera, et cetera. I wouldn't have to read it out to you, but this list on the left is what we started with. Then if we look on the right, what I noticed as I was going through each living lab is that most living labs have those characteristics, at least 3 of them, but most of them have almost 4, perhaps 5 in some cases. So that's good news, right? Every living lab is pretty much doing what the FEDeRATED project expects them to do. Most of these labs also have these characteristics in their own network of platforms, and let me explain that one. What I notice is that most labs, if you sort of take them aside and you pull them out of our project, within these labs, there is interactivity. Within your labs, you have multiple parties that are communicating via digital systems. Within your labs, you have processes between one of these parties. This is stuff you've been working on. And so this is actually really interesting, is that we're talking about the federated network of platforms, when actually each living lab is its own network of platforms. In most cases, there's a little network of platforms, right? And so, so within these labs, we have the characteristics, which is really interesting. Within each lab, I think most of the models you use for your data, we refer to them as semantic models, is actually specific for your lab, right? I could certainly say for aviation, we have our own semantic model that we use. There are some other labs that have their own semantic models. There are also labs that have their own databases and data models, but they're specific for each living lab, okay? And it typically reflects whatever it is that the lab is focusing on. So if it's rail transport, we're talking about a rail semantic model. If it's aviation, it's an aviation semantic model. So each of our labs have their own language. That part is also quite clear. And then the last one is a little bit of an issue here, is that most of the labs do not actually overlap in geography. There are some exceptions, like Sweden, and I suspect that the Swedish living labs have the biggest chance of being able to interoperate for that reason, is that there's already some connectivity in terms of what these labs do and the geography that they cover. But a lot of the other labs do not share geography unless, say, for example, in Finland, you have 3 living labs. One party has 3 labs, and obviously they're all in Finland. And so there is some connectivity. So within those groups, it works. But outside the actual federated partners, most of the labs are actually not overlapping in geography. And so this is, in a way, if you think about it, this is obvious. We only have so many partners. We only have so many projects. So there's no way that we could possibly expect to cover the entire European geography for all the types of services that we provide. So this is an observation. and it leads to an interesting conclusion, I think, is that if we want to connect our living labs, we may not be able to do that in an extremely useful basis. What I mean with that is that if we have if we've done all the analysis that we talked about before, and we look at the living lab and we say, well, we are all about cargo tracking, okay? And there's another lab that says, yes, we're also about cargo tracking. Can we do something together? Well, you can, except that one may be tracking cargo on the railroads in Sweden and the other on the rail in Spain. And those journeys will never connect. That was never the plan. It's not what it is. So we may have similar services. We may have a similar focus of the lab. We may even have similar data. But on a practical basis, our labs do not connect. Physically, they do not connect. So that's just, I think, a consequence of only having 23 labs and not having 1,000 living labs, which, of course, would never work. So it's what it is. Can't change it. So what does that mean? Well, what it means is that when we look at this beautiful semantic model here that I showed earlier, the reality is that each living lab, in a sense, has its own ontology, its own semantic model. I mentioned that earlier. And so when two living labs start talking to each other, we're talking about two very specific models that still need to interact via the semantic model of FEDeRATED, but it isn't that beautiful picture that I was suggesting, that aviation and road and maritime somehow only have one or two models. That's not the case. In reality, one living lab with another living lab, they can connect, but they're not using some common semantic model, right? It's their own model. We can still connect to the semantic model of FEDeRATED and then come out on the other side and link two living labs. So that's something to keep in mind, is the theoretical picture that I presented earlier was theoretical. In practice, we're going to be much more specific. So I think this is when I get to a point that I think is a crucial point for the FEDeRATED project, is exactly which living lab can speak with which living lab. In other words, we need some sort of speed dating process where we talk to each other. Living lab 1 talks to living lab 3. No, not 3, because they're the same project, but living lab 1 talks to living lab 16 and says, what do you guys do? What do we do? What connects us? What doesn't connect us? Is there anything that our labs have in common that would allow us to test some sort of interoperability? And I think we did that. I don't think the process is finished, but we did it in Delft, in the Oude Jan, right? This is the cafe where we went after the meeting, and I'm hoping, and I had to leave early that night, but I'm hoping that some of you people did this, that we didn't just talk about rock music and beer and whatever that was very important, that somehow in the back of our minds, we're actually talking to the other labs to say, well, what did you do? What can we do together? If that's not the case, and I'll be honest, I don't suppose this came to an end. It certainly continued the next day during the meeting, but we need to have that conversation. And so that is probably the most important homework I'm giving you, is please look at the description of the other labs and ask yourself, is there anything in the other lab that we could do something with, that we could interoperate with? It's not until we answer that question that we can do anything that resembles federation. That is, it should be an easy conversation, but we haven't done it yet. And so, or if you have, I know 1 or 2 labs have done that, but we need to come to that point. Which other lab can I work with? So that's an important one. I won't stop here because we can't have the conversation. That conversation is one-on-ones. Can't have that here, but we need to have it. So now let's assume you did that. Let's assume that you looked at the other labs, at the 23, and read through their descriptions. It will take you an hour, maybe an hour and a half, but it doesn't matter. It'll take you an hour. Go through them and ask you, hey, hang on, that living lab 19 does something that matches what we do. Let's reach out to them and have the conversation. And so I've just picked some fictitious labs one less fictitious than the other, or maybe they're both not so fictitious. But so we have one lab that is focusing on the movement of perishable food from Venice to Rome, right? And there's another lab that does last mile services in Linköping. What they have in common is that they're both using tracking services in order to be able to determine estimated times of arrival, etc. And so they have something in common. Now, of course, from a geographical perspective, this doesn't work, right? There's no point in moving perishable food to Rome and then distribute it in Linköping. This doesn't work. But from a test perspective, we could make this work. We could make it work because what the lab on the left does, lab X, matches very well with what the lab on the right does. In terms of, I have freight, I move from one hub to another, I pick it up from the hub, I do a last mile service. And even though in reality the two don't link up, from a federated lab perspective, we can make that work. So I say this is a bingo. And you're going to have to take that view when you look at the other labs. Because what you won't find, this will be a very short exercise for you, what you won't find is another lab that will somehow connect to what you do. They don't exist. Or if they do, it was by design already, and you already know it. But you're not going to have a nice surprise. Say, oh, that's really amazing. Lab 6 has exactly the same IoT approach as we do in Lab 19, and the road transport connects. Okay, it's not going to happen. So we're going to have to be a little bit lab-like about this. Lab meaning, we do experiments. Let's think of it as an experiment, not as a simulation of reality. But it's an example. And so now we can go all the way through the process of let me go back to the earlier thing here, just show you. Yeah. So we've covered the first box. We now actually know which lab we want to do something with. And we can now do the rest. Okay, so the first one, we ticked it off. We did our speed dating. We went to the pub in Delft. We had other conversations. We studied the other labs. We know who we can do something with. We had a phone call. We had a meeting. Yes, we're going to do something, and we're going to keep it simple. Don't try and do complex stuff at this point. It's not necessary. So in this case, I have a lab X and a lab Y, and they're just going to be trying to match up their services using ETAs, ATAs, ETDs, etc. Right? Some simple concepts. So what do we do? So take a deep breath. I didn't lose you earlier on. If I lose you now, tell me and I'll repeat it, because it's not as hard as it may seem. So just focus on the left first. When we look at these two labs, that should be lab Y, not Z, obviously. Fix that once and for all. Okay. Okay, so we have two labs, living lab X and Y, and we're going to see what it is they can do together. So this is the example of this company that moved freight from Venice to Rome, and another one that understands last mile delivery. So what is it? If you look at the first part on the left here, okay, so who will be delivering the freight to that terminal, where it needs to be picked up, what sort of freight is it, weight, volume, how many pieces, whether we expect the freight to arrive, when did it actually arrive, what is the location for that last mile service, who will actually deliver that last mile, and then the dates and times and everything that comes with that, who is it supposed to go to and what are their details. Without knowing anything about road transport, in this case, and last mile services, I know nothing about these things. It's not my domain, but these are the sort of questions I imagine are relevant. These are the sort of data points that you'd want to understand to be able to do that. And there may be other things that are very specific to your mode of transport, give or take. It's the sort of questions you would ask. And if you look on the right, so we have this transport company and then the last mile services company, or lab, I should call it. They have a very simple interaction. Hello, ciao, hi. No, hey. My Swedish is not what it used to be. Nor my Italian for that matter. But anyway, so we say hello. We'll come back to that in a minute, why we say hello. But anyway, we've said hello. And so the transport lab says, okay, I've got some transport data for the last mile. Here it is. And then the last mile says, that's great, we can do something with that. And this is how we will deliver our services. And they give some data back to the transport living lab. Once they have agreed on all of that, at some point the transport living lab will say, look, freight is being delivered to your terminal or to your hub, and for you to pick up. And then at some point, the last mile living lab will say, fine, I got it. It's been delivered. Here are the details. Very simple process. It's obviously a simplification of perhaps how things are in reality. But since the purpose of what we're doing here is to test interoperability and not to implement a fully fledged transport service, this is good enough. This is good enough for now. And we can take it to the next level over the next 12 months or 16 months or whatever it is. But for now, this is all we need to do between two living labs that share something. And obviously, again, this is a simulation because unfortunately the freight arrives in Rome and needs to be distributed in Linköping. Doesn't work, but it doesn't matter. Concept is the same. And I see that somehow the subtitles came back. And I can't get rid of them. Oops. Okay, never mind. We'll have to live with those for now. Okay, continuing from here. So this part should be understandable. Before I go on, are you still with me here? Is this still something that you can follow? Is this still something that you could do for your own living lab, perhaps in conversation with another living lab?
Yes, for me, Sjoerd here, Henk, for me, it's quite understandable and workable for our living labs.
Okay. Then.
Yes, Henk, it is a good method to start talking between each other. I think it's a good idea the way you propose it.
Okay. Then let's say, yeah, go ahead.
This is Lasse from FEDeRATED. I think this is exactly what I would like to see now when we have this new collaboration between the living labs that Sjoerd, you are now drafting there. This is exactly what we should do there.
Yeah,
make
sure,
that bluff that we were discussing maybe in Delft, but now also add some concrete actions there.
From bluff to action, Lasse.
But you agree, right, that these are actually simple questions. This is not rocket science. You don't need to be an IT, and this is actually an IT person couldn't do this. This is not an IT job. This is a business job. This is what you guys do. This is, forget IT. They wouldn't understand this. What they understand is the next part, and that's why I just wanted to give you a time to breathe. Okay, so let's go to the next part. So, sorry, let's go back to the first one. So let's go back to the data. What I've written this in a normal language. Who delivers the freight to the terminal? Whether that's Rome or Linköping, it doesn't matter. But who does that, right? It's a question. You need to understand that so that when you get to the terminal, you know which truck to look for, right? This is a very basic question, but it's the sort of question that we need to answer. So how do we implement that? And this is when the screen may look complicated, but the question is the same. So this is just an example. Who delivers the freight to the terminal? And so I went to the website, and you know what? Let me just check the time. Yeah, I think we're good. Let me just bring up a browser, and let's do this together. Right, here's the Audion portal. Here we go. Now, if you go to the FEDeRATED website, right, you all know what that is, hopefully, and that's the developer portal. Whether you spend time on that, I don't know, but this is a good chance to do. Just click on it, and you get to general introduction, and there's also a tab called documentation. This takes you straight into our semantic model. And what you'll see is that although the interface may look a little bit techy, it's not as complex as it actually seems. The only trick to know is that I want you to click on classes. I won't go into why I want that, but there's sort of a relatively high level. It's the highest level description of our semantic model. And we can just browse through that. So let me just put this on top of the screen here. And if you were to browse through it, you can see things like business roles, importers, senders, We have commercial roles. These are all things that we recognize. We know where the customer is, right? And so let me just collapse these actor roles, and we'll see others. For example, we have classifications, what different container types. So I'm just sort of having a look here. Itineraries, legal persons, very interesting. Let me just close some of these tabs because I don't actually want to look at those at the moment. So what you're seeing here is a live demo of how you browse through the data, and I'm just closing tabs here. Okay, so this is not actually a demo at all, but just to show you what we can do with this. So we had a question, and the question was, who delivers the goods? Now, the party that delivers the good is probably somebody who provides a logistics service. Okay, so when you scroll through this, you might say, well, it could be an actor role, possibly. In fact, that would make a lot of sense. And we have some business roles. No, that's not it. And you're going to do like I do. You just browse through it. Commercial roles. Actually, there's a service provider. That kind of makes sense, doesn't it? It's the party that provides the service. And what you can see on the right here is actually you can't, because for some reason the text is still uncreated, but I'm going to cheat a little bit and click on source, and then we see the whole text here. And the whole text says that a service provider is any enterprise that is able to perform a business activity on behalf of its customers, can be identified as a service provider. Activities defined by the business services and timetables, etc., etc. So this is certainly something that perhaps is relevant to who is that party that is going to be delivering the freight to my hub, to my terminal. There's some other things in here that kind of make sense there. We skipped right over it earlier on. See if we can still find it. Logistics service is another one. And so we have, for example, a transport service. Well, that's perfect, right? This is a transport service. So what you're going to do is what I've just done is going back to the presentation. Here it is. And I full screen again. I asked the question, who delivers the freight to the terminal? Is it the business party or is it a service? Well, you know what? I'll let you think about that. Is it a service provider or is it a logistics service? Don't have to decide at this moment in time. But that's what you're going to do. And coming back to the previous slide here. So you have these questions here. What type of freight, weight and volume? And when you go through that exercise, like I just did, you're actually going to find, without spending an awful lot of time, answers to all of these questions. And I've just put them together here. And so who delivers the freight? Well, it's a service provider, which happens to be in a class called logistics roles. Okay, we won't go into the technicalities here, but just going through the semantic model, you will find that each of the way we described it in English, there's a way that we've described it in the model, which makes sense. So what type of freight? Well, you could look at cargo type or nature of cargo. They're both correct. Okay, you could look at that. Questions like weight, volume, and the number of pieces. Well, there they are. We have a cargo weight, we have a maximum volume, maximum size, and that sort of could be useful, right, to describe that. There's other questions, there's the, where's the location? Well, this is the place of delivery that we're talking about. Where would that be? Well, it's in a city. It happens that in our semantic model, that's referred to as the physical infrastructure ontology, and then the element or the class is city. But that's okay. We found it, and we just written it down as we found it in the model. Incidentally, just to show you how I found that, because I don't want to be cheat too much. It's cheat enough as it is. When I looked up, what was it earlier on? Actor, and was it service provider? And you have the documentation. Actually, if you click on source here on the right, then at the very top here, you actually see that this is the actual description of this thing. And so I've just picked the last part here, which is a logistics role and then hash symbol service provider. And so in my presentation here, I've just copied that. Okay. It's nothing, I didn't add anything. So, logistics roles, hash service provider. And so all of those, you find them like that. And so I find nice descriptions of nice semantic representations of the questions I have on the left, including events. I have an ETA event, ATA, etc., etc. I also have decided I needed a consignee somewhere, so fine, I found a consignee in the model, so I'm happy. So this exercise is just a case of browsing. You're going to see afterwards that this will raise lots of questions, but they're really good questions, and you need to bump into these questions to fully understand how to interoperate. But okay, I've done it for you. It took me about an hour. I'll be honest with you. It did take about an hour to go through and find the right elements, but now I have them. And all I have to do now is just put them in a file. Now I'm using this format I referred to during the meeting as JSON-LD because I find it very readable. But what you see here, we could just read through that. We don't have to, it's not so complex. I'll skip the first line, I'll come back to that one. I've just defined in the context something called FD, which is a prefix, FD, and it means HTTPS ontology TNL.nl logistics federated / okay? So whenever we see FD, that's what it means. So in the next session, you see lots of FDs, and it's just to keep the line short. It's a way of saving characters, I guess. And then we see, you know, logistics role service provider, and there's this non-existent company called Italia Veloce Logistica that is going to be taking the freight to Rome or to Linköping or wherever it is they're taking it. I found some, you know, it's general cargo, nature of goods, consumer goods. I don't think that's an existing categorization, but we'll come back to that. Something about weight, volume, place of delivery. There's even the consignee there and some non-existent company whose name I'm not going to attempt to pronounce, but I did look up. It means something like good computers or best computers or something like that. There's an ETA event time in the correct format, or rather in the ISO format. And I've included a booking number, which will be useful in the subsequent exchange. So you can see how from the previous slide, where on the left, I just described the data that we need in a language that we all understand, being English, to the words and the classes or elements that we find in the federated ontology just by browsing through it. And I've put them in a file in whatever order, and I've actually put some real meaningful data behind it. So this is the sort of data that you would expect the transport living lab to send to the last mile living lab, right? That's what it is. Now, there's the format here. It's JSON-LD. In fact, the very one I skipped, the first one is the is a URL, which you can see there. They call it the ID in JSON-LD, but actually it's the URL of this file. So if you were to put this in your browser, you would get all the contents on the screen here. If this was real, it isn't real, but if it was real, then this is where the data is, okay? So fine, we're all happy. Transport company has sent this data to the last mile company. And so the last mile looks at it and responds and says, that's fine, okay. Booking number 464646. We confirm that this consignor, as far as we're concerned, it's the consignor Italia Veloce Logistica. We ourselves are last mile Linköping, and we confirm that we can pick up. We expect the freight to be departing from the hub in Linköping to the final customer at these dates, at these times here. And actually, you can look at the dates and times as they kind of make sense, right? The previous one expected to deliver at ETA event. What was it on 12th of April, which is tomorrow as it happens, at 2 minutes past 4. And the last mile says they'll pick it up at 5. Okay, probably the way that they're organized, they can't pick it up before 5. And of course, we assume that Italia Veloce Logistica is happy with that, right? If not, then they can say so. So that's the exchange. One party says, this is what I have for you, and the other says, this is what we're going to do with that. That's typical. And then when it actually happens, then the Italia Logistica is going to send a message saying, okay, we have actually an actual time of arrival, which is 22 minutes past 4, and some delays. And here's the booking number. The last mile will pick it up. Sorry, I'm going a bit quick perhaps, because you might want to read through it, but it's in the second part of the file, as you can see. Italia Veloce Logistica, I should have used Dutch, will pick up, has actually confirmed that the freight has an actual arrival event at 22 past 4, booking number. And then the last mile living lab says, that's great, same booking number, confirm that this was actually picked up at an actual time of 17:05, delivered to the customer in Linköping at 12:17, sorry, at 17:32, right? Here we have a complete exchange of data.
Henk, I think someone has raised his hand.
Okay, please ask, because I can't see that. So yes, please shout.
Yes, it's Eddie. What in this message is it that tells us that this is a confirmation and not just a suggestion or a request of a certain time? Well, for an actual, it wouldn't make sense, of course, but
so, okay, that's a quite a good question, and I'll go back to this here, to the process, right? So we agreed between the living labs that the process we would follow, we will send the transport data. The last mile will confirm that they can actually provide that service with the data that they need for, or that they will use for that. And then there is a transport delivered and a last mile delivered exchange of messages as well. So we agreed that we would do this. This is not some sort of standard process that we have invented for the whole of FEDeRATED. This is just two living labs that decided that this is how they want to exchange data. And so in the slides that followed, what I've shown you here is that first, there's the Italian company that sends this message to the last mile company, and they have a booking number in there. And actually, if you look at the URL, there's an order 123 as well. So these are some references that the last mile will understand. Then when they respond, the URL has changed, right? Last mile Linköping FEDeRATED delivery 432 and the order number. So already the two know that this concerns specifically that booking number. And then I keep repeating the booking number. Now, if you look at the URL, I skipped over that, but it actually says actual time of arrival. So the Italian company has sent this message. It happens to have an actual time of arrival in the URL. Now, this may not be meaningful, but it's something that we agreed between the parties that this is how we will do it. It's not this is not a standard process, but we have agreed that after we've confirmed the order, if you want, when it comes to execution, transport company will send the actual time of arrival, which is this message, and on receipt, when it's actually delivered, and I should have changed the, perhaps I should have changed the URL here, but the delivery 432 with the same booking number has that data. The question is, and it's a good question, is this enough? And in reality, I don't think this is enough. I think it's enough for showing you how we can exchange data. But in my world, I will add into that references to the actual URI of the booking. I would include a specific reference to the goods that have been delivered. I would include a reference to the specific addresses, etc., etc. There will be a lot more in this. So yes, this is not perhaps a workable implementation, but it's certainly a testable process. Let me put it like that.
Yeah, absolutely. I mean, I'm not trying to insinuate that this should be extended to work, because that's given since it's a simple example. I'm just thinking from the perspective of trying to visualize this in some kind of a user interface.
Yeah,
we will certainly need a bit more meta.
And that's it. That's exactly right. And so what happens, and this is answer to all of you, when you go through this process and you simplify it like I've done here, when you get that, and like Eddie does, right? He's quick. When he has it in his brain, he immediately thinks, hang on, I need more. Of course you need more. But it's easier to start with something that you comprehend in a few slides and then ask the question, okay, but that's not realistic, I need more. Then it is to start with something that's super complex. So by all means, go further, but you need to start, keep it simple. And then you do the rest. And like you said, you realize that. And you'll, it's actually, I think it's one of my next slides. It doesn't stop here. But so this is a relatively simple exchange. And again, did I lose people? And don't be embarrassed if I did lose you, because that says more about me than it says about you. Did I lose somebody so far in this process of explaining it? Either I didn't, or I completely lost you, but that's fine. I
think the trick here is to actually find the right class to use. That's the trick in here. Actually aligning your proprietary semantic model to the federated semantic model. I think that's the trick. That's why it took you 1 hour to figure this out.
Exactly. And you know what? If you can't find it, cheat. Just cheat. What does cheat mean? It means that if I can't find, for example, an answer to address details of the consignee at the bottom left here, sorry. And by the way, I didn't, okay, which is why you didn't see it. You need an address, right? You can't deliver the last mile if you don't have an address. I didn't find it in the semantic model, so this then raises a big question, and you have to contact me and say, hey, hang on, you guys don't have an address. What am I supposed to do with this? And then I contact Cornelis. Cornelis, what do we do? Panicking, we need an address, right? So not everything is in there.
No,
and even if it is, it may not be exactly right. So what happens then is just make it up and put it in and just say consignee address at the sort of when you get to the first part here, this is the transport company communicating with the last mile, and it doesn't provide the address. It has the consignee name, but not the address. Yep. Just type address and then whatever the address is. So that's okay, because on one hand, it will make it work for you. And on the other hand, it's feedback to us to say that our semantic model is incomplete. And we need to have that feedback. Yeah. So it's a two-way process. Yeah. Okay, so again, I think I still think this is straightforward. I know, when you start putting in hashes and ats and colons, it's easy to get confused, but don't worry about that. The actual message is simple. So, question is, are we ready to federate our living labs? And I will repeat the most important steps to find another living lab that has anything that you can exchange with. That's the key question at the moment. And so the questions you just raised actually are the ones that I've captured here. My data doesn't match the federated model. I cannot find an address, which is crazy, right? We need an address. So that just write it down, and whatever isn't there, let us know, and we'll find a way of getting it in there. And in the meantime, you just use your own model. That's fine. I kind of skipped over when I talked about the process, and I said ciao and hey. I kind of assumed that these companies already knew each other, that they already have a relationship. Of course, that may or may not be true. So there is a question: how did the transport company find the last mile service? Now, maybe through speed dating, whatever. Certainly for the labs, that will be the case. But this is when we go into other services that we won't be covering here, but things like an index of services or searching for services. Somewhere along the line, two companies have to find each other. And now you see why, right? Because how can you exchange data if you don't have the details of the other service? So there's some other stuff that's happening in the background that I didn't cover here. But for the purpose of linking up two living labs, let's assume that you know each other, and let's even assume that you trust each other. So we can skip a lot of that stuff and just go like, hi, hello, I'm here, let's exchange data, right? But it's an important question. How did they then initiate that data relationship? Because just putting a file on your computer isn't going to do it, right? Okay, I have it on my screen and I could send you a copy, but you can't exchange data on that basis. So there are still some questions around how do we actually get to know each other? How do we exchange data? And then another one is, how do you notify each other? Because the model that we're presenting here has the assumption that the last mile knows that the transport company has data for them and they can go and get it. Remember the first file that I showed you? This one here. So this is the Italian company that is sending freight to some hub, expecting a last mile to pick it up. So it assumes that the last mile has actually received this somehow, has accessed it. So what are they supposed to do? Are they supposed to try any URL on the planet until they find this one? No, of course not. And so there are still some mechanisms around the API that aren't covered here. In particular, the things like the pub sub or pushing data, or this is still stuff that is around the architecture, we're not covering here. And for the purpose of doing interoperable testing for semantics, we don't care too much. But if you think about it, it's not realistic, right? How are they supposed to know? So there are still some questions there that we need to answer, and they're being answered on the architecture side in particular. But for us here, semantics, if we're able to translate that potential interaction between two living labs into simple terms of what the data is they exchange, what is the process, put it into a format that has some compatibility with semantics, then we can go and implement it in the next session. In other words, make it live, put it on the internet. We're going to do that. You're going to do that. And then in the next session, now we start querying each other and getting really interesting answers to interesting questions. Okay, so that's roughly the game plan here. The purpose of today was to get this far. So what have we done? We've understood what is a federated platform. I think we sort of have an idea now. What does it mean to have interoperability? What are the sort of things that we do? Remember these characteristics of cargo tracking, visibility, and all that stuff. These are the sort of things we pursue. The next question is, okay, if I want to find another lab, how do I describe in very simple terms what services my lab provides? What sort of things do I do? I can now read through all the other labs and say, okay, that kind of makes sense. Let me have a chat with this guy and see if this lady, what sort of exchange we can do, have a call, exchange some stuff and say, yes, agree, we're going to do something as simple as what I've just presented. So that's that. So now we know what it is we do, what's the process, what are the sort of data, let's put it into a file, and you're ready. You're ready for the next step. So that's sort of your homework. Actually, your main homework is find another lab and ask yourself some questions so that when we start at the next session, we actually implement something like this, then you can also do the same thing in your own living lab. Okay, and then the last one is about the actual interaction via queries. So the questions that I've said here, they're important because they'll give you more insight into semantics, into the architecture, and like we discovered, the address is missing. Fine, lots of questions we still need to answer, but we'll discover them together. Next sessions, as I said, the next one very specifically, we'll look at how to implement these adapters. And don't worry if you think that's technical. I think it will still help to understand how that works, how we implement it, how you can install your own semantic adapter, and then we'll upload some data. In fact, you'll upload exactly the data that we've just created together, but you'll do it yourself. And then the last one, we will look a little bit about how we then actually get the data. We call that queries, essentially asking questions to the other lab. How you can write those, we'll give you some cheat sheets, i.e. examples, and then we can wrap this up. And at that point, we'll have proper interoperability between our labs implemented at least at a semantic level. Okay. So that's the plan. Back to you, questions, comments. Yeah, back to you, basically.
A comment from me, Henk, from Luxembourg, Switzerland, Henk, 12 points.
Ah,
well
okay.
done, Henk.
In that case, you're supposed to say 12 points, 12 punten, 12 punten.
Yeah, well done, yeah.
Well, agree with Rudy, Henk, very well explained. And in fact, Lasse, Mika, Rudy, Alessandro, Alessia, we are about to perform this in our combined living lab, which we spoke about in Delft. So let's get that work done. Next Thursday, I will invite you for a second meeting, and then let's go ahead.
Excellent. That's really good.
Yeah, I think this is on the agenda for a meeting that we have in 3 weeks here in Sweden as well. So if you have pointers to other documentation for those of us that are probably going to be leading that exercise or having a leading role, that would be great. And this presentation, of course, I think it's been great.
Yes, I will share this, and honestly, and my appreciation to all of you that have helped Roland and Alessia to put all these living lab sheets together. Almost everything you need is in there. Almost everything, certainly for this level. When you're going to take it to the next level, that's a whole other ball game. You're going to go much deeper, but certainly for this level, the info was there. Yeah. And don't hesitate to contact me if you say, well, we're not sure how to do this and that. By all means, ask me or ask anyone else, but ask me certainly.
I think on behalf of the project coordination, I would also like to congratulate you on your presentation, Professor Mulder. It's a landmark result. Preferably, it would be great. We have also our own YouTube channel to have it as soon as possible be published on the YouTube channel in order to show the world where FEDeRATED is all about and how easy it is if you can follow you till the end, I think.
Okay.
Most appreciated. Very well done. Thank you.
Thank you, Roland. I'm going to be fighting with the recording. I have no idea yet how to get it out of the system, but there is a recording, so that's the good news. Okay, good. Well, if there's nothing else, thank you very much for your time and for your attention. I will share this. Obviously, I will send it by email for starters, and then we can figure out where else to put it. Try and do the exercise. Honestly, once the key is finding a partner actually, and it shouldn't be that hard. But once you have that conversation, the rest will follow. And if it doesn't, let me know, and I will put you back on track and make sure you get there. Because in the end, we want to see this interoperability in action and not just on paper. So, very good. Then I wish you a nice evening.
Thank you very much, Henk. Thank you for your
Bye.
presentation.
Thank you.
Bye-bye.
Bye-bye.
Bye-bye, colleagues. Ciao.
Thank you. Bye.
Bye.
Afternoon.